Pi Node Decentralized Computing Case Study. Hello, dear Global Pioneer family. Today, I am here to share the content of our latest blog post, Pi Node Decentralized Computing Case Study. Pi Network is exploring the ability of Pi's global node network to support decentralized AI training and computing tasks. The original design of the Pi node goes far beyond just securing the ledger. Although the Pi blockchain benefits from the decentralized nature of numerous distributed nodes across the globe, the Pi ledger itself is extremely energy efficient and does not require the full computing resources of such a massive distributed node network. This creates a pool of idle computing power that can be used to develop new applications, such as decentralized cloud computing. Third parties who need computing power for AI model training can utilize these idle resources from Pi node operators, who can choose to opt in and be paid in cryptocurrency. Applications on Pi nodes, along with Pi apps, platform-level utilities, and local commerce activities, constitute a significant part of Pi applications. This node utility aims to address two emerging problems in the AI era. First, the limitations of centralized computing, issues including data center constraints, energy concentration, and catastrophic forgetting or global state bottlenecks. Second, the growing demand for AI-driven computing. As AI models and agents advance, and the AI economy expands, the demand for computing resources grows with it. Society needs to provide unprecedented computing power to support the development of the AI economy, which requires creating new computing power wherever possible and fully utilizing existing unused computing power. Fragmented and unused computing power needs to be aggregated, coordinated, and scaled through distributed networks and technology to exert its proper utility. Pi possesses unique advantages to solve these two challenges. Because Pi itself is a distributed network with over 421,000 nodes, representing over 1 million CPUs that support distributed computing. Furthermore, Pi has tens of millions of participants, verified by KYC, who can choose to provide human support for related AI learning processes and receive cryptocurrency as compensation. Combined with the computing power of Pi nodes, this can provide scalable, authentic human input for AI systems, thereby further perfecting a one-stop service for AI clients. Together, these elements offer new approaches for AI infrastructure, enabling distributed systems to incorporate production activities into their networks, allowing people to contribute directly to the AI production process and receive returns through blockchain-based payments. Last October, Pi successfully completed a proof of concept project with OpenMind, in which a small group of Pi node operators ran image recognition tasks for the company. OpenMind case. Study OpenMind is developing an operating system, an open source protocol, to enable robots to think, learn, and work collaboratively, similar to an Android operating system for robots. Like other physical AI projects, OpenMind requires powerful computing capabilities to train, evaluate, and run its models. To test the feasibility of Pi distributed computing, OpenMind developed a container that can request computing tasks from individual computers. The team shared this container with volunteer Pi node operators, who downloaded and ran it on their own machines. Subsequently, OpenMind sent tasks through the container, requesting computers to process different images using OpenMind's AI image recognition model. This is a typical use case, illustrating that image recognition training is crucial for OpenMind robots to interact with the real world. The goal was to use the computing power of volunteer Pi node operators to discover as many discrete objects as possible in these images. Results: the proof of concept project ran successfully. Tasks were correctly pushed to external testers, volunteer Pi node operators, and valid results were sent back to OpenMind. The use case was validated, meaning Pi nodes can choose to run calculations defined and requested by third parties unrelated to their own blockchain obligations, and return meaningful results to third-party clients. Key statistics of the pilot project: 7 volunteer Pi node operators participated in the test. The end-to-end distributed pipeline ran successfully. The posted job opportunity received confirmations from 7 workers within 1 second. Within 4 seconds, multiple worker processes returned inference results. The results contained correct object detection outcomes, including expected labels, such as bus and person and bounding boxes. The job was successfully pushed to external test machines and returned valid detection results, validating the reliability of the distributed broadcast and result return path. Overall, this experiment validated that distributed Pi nodes can execute AI-related workloads and return useful results quickly. Next steps distributed AI training is currently still in the global research stage. Researchers and related enterprises around the world should continue to deeply explore the feasibility of shifting from fully centralized AI training to more distributed methods. Such research is directly related to the challenges mentioned earlier, resolving the structural limitations of centralized computing, utilizing fragmented and unused computing power for AI development, and creating opportunities for individuals to meaningfully participate in AI-driven production. By evaluating how unused node computing power supports external AI workloads and packaging computing power with real human input, this initiative may provide an alternative infrastructure option for AI companies and startups when seeking solutions to meet their AI training needs. In general, Pi's research on node utility complements Pi's vision for the future of blockchain and AI, a vision where decentralized infrastructure contributes to various components of the future economy and supports fair participation and distribution.